Let's take a look at section 5.3 on exponential and logarithmic integrals. So we're going to be able to use the exponential rule to find indefinite integrals and use the log rule to find indefinite integrals. So remember, integrals are anti-differentiation, the opposite. So we know that the derivative of e to the x is e to the x. So that means the antiderivative, or indefinite integral of e to the x, must be also e to the x, moving the other direction. But don't forget that plus c, which is that arbitrary constant. Likewise, we know that e to the u du dx with respect to x equals e to the u du, which is e to the u plus c. In other words, that's the chain rule working backwards for the exponential rule. So let's take a look at this right here. The first one, it says find the indefinite integral. The first one just has a constant multiple of 3, so pull that out in front. You would end up with 3 times the integral of e to the x dx. We know that the integral of e to the x is indeed e to the x, and then we need the plus c. So the answer would be 3 e to the x plus c. Let's go ahead and look at b here. So if it's not an x in the exponent, anytime it's something more than x, you're going to have to use that u substitution. So let's go back to that u substitution where we're going to make u whatever the exponent is. In this case, it would be 5x. Then remember, we take the derivative of u with respect to x, take the derivative of the right-hand side. The derivative of 5x is just 5. And then I go ahead and solve for dx. Solving for dx, I'd multiply both sides by dx, divide both sides by 5, and I'd have dx equals du over 5. Now the trick is, what I'm going to do is I already know what u is, and so I'm going to substitute that in, and I also know what dx is. So I'm going to substitute in for dx. So let's rewrite this integral in terms of u's and dx's, replacing dx. This would turn into the integral of 5, then it would be e to the u, because 5x is u, and then instead of dx we would do du over 5. Notice our 5 simplify here. We're left with the integral of e to the u du. Since our variables match, we can integrate. We would end up with e to the u plus c. But don't forget, you always need to back substitute for u. U was 5x, so it looks like we'd have e to the 5x plus c as our final answer. E to the 5x plus c. Again, remember, anytime you anti-differentiate, you take an integral, you can always check your answer by taking the derivative of your answer. Notice the derivative of e to the 5x plus c would be e to the 5x times 5, which is the original problem. Let's try the next one. It says, what is the integral of e to the x minus x? Again, we could separate this into two separate integrals. The integral of e to the x minus the integral of x. Of course, both of these are with respect to x. The integral of e to the x is e to the x. The integral of x is, using the power rule, x squared over 2. And then we have the plus c, that arbitrary constant. So it seems to me our final answer would be e to the x minus x squared over 2, or you could have written that as 1/2 x squared, plus c. Again, we can check our answer by taking the derivative. The derivative of e to the x is e to the x. The derivative of x squared over 2 would be 2x over 2, which would simplify to be x, which would give us our original problem as desired. Let's go on and let's look at example 2 here. It says integrating an exponent or an exponential function, find the integral of 5x e to the negative x squared dx. Again, notice that the exponent here is not just x. Whatever's in the exponent, that is what we are going to make u. So we're going to say let u here be the exponent, which is negative x squared. We take the derivative of u with respect to x, take the derivative of both sides. The derivative of negative x squared would be negative 2x. We solve for dx by multiplying both sides by dx, dividing both sides by negative 2x. You would end up with dx equals du over negative 2x. And then remember, the goal is to substitute in for u and also substitute in for dx. So let's rewrite that original integral. Looks like we'd have the integral of 5x stays the same, but then we'd have e to the u, and then instead of dx, we have du over negative 2x. Let's see what happens here when we do some simplifications. Those x's are going to simplify. We can pull out our constant multiple I'm going to have negative 5/2 as my constant multiple. Remember that negative 2 does need to stay on bottom. Then I'd be left with the integral of e to the u du. Now my variables match, so I can actually integrate. So this is going to be negative 5/2. The integral of e to the u is e to the u. We never forget our trusty plus c. Last step is back substitute for that e to the u. So that's going to be a negative 5/2 e to the, well, it would be negative x squared plus c. So that would be our final answer for the problem. As always, we want to double check our answer. The derivative of negative 5/2 e to the negative x squared would be negative 5/2 e to the negative x squared, but then you'd need to multiply it using the chain rule, would be times a negative 2x. The negative 2x's, the negatives would cancel, the 2's would cancel, and you'd be left with 5x e to the negative x squared. And that is the original problem, so that is the right answer.